In this lesson, we'll be talking about the basics of petroleum technology. We'll begin by asking ourselves what fossil fuels are. What are fossil fuels? Fossil fuels are hydrocarbons, primarily coal, petroleum or crude oil, or natural gas, which are formed from the remains of dead plants and animals. Currently, fossil fuels supply roughly 80 to 85% of the world's energy, and that's enormous. This is one of the reasons many people are saying it will be very difficult to replace fossil fuel with renewable technologies. However, efforts are being made to ensure that happens. But then the truth and reality on the ground is that most of the world's energy today have been supplied by fossil fuels. If renewable energy cannot meet this demand, then this 100% renewable energy world is still a far cry. Again, scientists are working, technologists are working, the entire world is working to make sure we make the world a safer place. But then we have to find the middle ground between the use of fossil fuels and renewable energy technologies. There are three main fossil fuels. We have the coal, we have the petroleum, which can also be referred to as the crude oil, and the third one is the natural gas. Coal is cheap and abundant, but it releases a lot of pollutants when it is burned. Petroleum or crude oil is harder to find and is typically a bit cleaner when burning it. Unlike coal, it can be pumped through pipelines and easily refined into fuels like gasoline, kerosene, and several other fuels. And thirdly, natural gas is also relatively inexpensive and less polluting than coal or crude oil. How is coal formed? Very briefly, let's look at this. Organic matter derived mostly from land plants accumulates in low energy environment like the swamp. So you can see the swamp environment somewhere right up here. Oxidative decay uses up lots of oxygen, rendering the sediment poor waters devoid of oxygen. So gentle cooking and pressing, which is usually referred to as lithification, as a result of increasing burial depth, remove the poor water and increase carbon content. Lower grade coal tends to contain minerals such as pyrite, which are formed under the reducing conditions or low oxygen conditions. So as you can see we have the lignite, we have the anthracite. The lignite is a low grade coal, while the anthracite is a high grade coal. The anthracite is hard black coal. It is used in industry and it has high energy. It requires a lot of cooking, while the lignite is soft. It is brown coal and it has moderate energy. It requires just little cooking to be formed. Now, what are the uses of coal? Coal is used as fuel. Coal is a very important fuel throughout Asia and remains highly significant in the USA, which has the largest non-coal reserves in the world. It is also used as coke. Bituminous coal that is cooked or charred to remove nearly all the remaining volatiles is transformed into a spongy substance called coke. Some of the removed gases, such as methane, can themselves be used as fuel. So both coke and then some of the byproducts can also be used as fuel. Coke has many uses. It is predominantly burned in the blast furnace to smelt iron from iron ore. It is also used in the production of cement by cooking limestone and silica. Some byproducts from processed coal are also very useful. We've talked about a couple of them. These include organic substances used to make some plastics, medicines, and solvents. Artificial sweeteners such as saccharin and aspartame are also derived from byproducts of coal. So you will see the aspartame chemical composition here, and then you can see some of the other products that we have. Okay, so these are edible products. Okay, and you can see the chemical composition of aspartame here. Let's tilt our discussion towards oil and natural gas. Oil and natural gas consist of various hydrocarbon compounds and they are produced in a similar manner, though they are typically derived from different sources of organic remains. They are derived from the remains of marine plants and animals, mostly called plankton. Oil and natural gas result from the chemical breakdown of these remains in the absence of oxygen as depth of burial increases. And as this depth increases, certainly the temperature increases. The oxygen and nitrogen in the original organics are driven off, leaving behind hydrocarbon compounds. These hydrocarbon compounds are mainly made up of carbon and hydrogen. How is petroleum formed? Oil and gas result from the breakdown of organic molecules under conditions of increasing temperature, from large complex molecules to smaller, shorter chain molecules dominated by hydrogen and carbon. This process is called cracking or pyrolysis. This occurs largely through the breaking of carbon to carbon bonds. Some gas are produced by decomposition of organic matter by microbes. This can also be called biogenic gas. Most oil is produced at temperatures between 60 degrees and 120 degrees. This is usually referred to as the oil window. Thermogenic gas is produced as oil is broken down to very small molecules. The smallest molecule is referred to as methane. So when we say oil window, you can see that we have the lower limit and then we have the upper limit. Below the lower limit, organics remain largely unaltered, and above the upper limit, thermal cracking transforms the petroleum into natural gas. Now there is an important term called petroleum traps, and let's quickly delve into that. A geologic environment that allows for economically significant amounts of oil and gas to accumulate underground is termed an oil or petroleum trap. Oil and gas is contained in a reservoir. A reservoir must be permeable to oil and gas and contain sufficient interconnected pore space to accommodate the petroleum. Common examples are poorly lithified sandstones, carbonate reefs, and diagenetic carbonates. The roof of the trap must be made of material that is impermeable to fluids. This is necessary to prevent the upward escape of oil and gas, which are much less dense than the surrounding rock. Common traps include the anticline fold traps, the fault-bound traps, which are usually referred to as the structural traps, as well as the various stratigraphic traps. There are three primary forms of oil traps. And in all of these three cases, oil and gas accumulates in a restricted area, and the top of the permeable reservoir rock unit is sealed by impermeable cap rock, as we shall soon see. As we can see here, this is an anticline fold trap. You can see we have the oil somewhere here, and then you can see we have the cap rock. Okay, these are reservoir rock, and then you can see we have the cap rock. These are impermeable. This cap rock is impermeable, and this is our oil right here. Then we also have what we call the fault bounded trap. In between this cap rock, you can see we also have a reservoir rock, this layer, you can see that, and then we have the cap rock here. So the reservoir rock, as you can see, you have it here, and then the top of the reservoir rock is impermeable cap rock, and this is the impermeable cap rock right up here. Then thirdly, we have what we refer to as the stratigraphic trap. Again, you will see that we have the reservoir rock. You can see the layer of the reservoir rock. You can see that here with this, and then right above the reservoir rock, we have the cap rock that is impermeable. Okay, these are three popular forms of oil traps that we have. Now let's talk about recovery of oil and gas. How is oil and gas recovered? We have said that we have reservoir rock, and on top of the reservoir rock, we have the cap rock, and the cap rock is impermeable. Okay, when the cap rock is penetrated by drilling, the oil and natural gas under pressure migrate from the pore spaces of the reservoir rock to the drill hole. Before methods were developed to control the upward flow of oil in wells, dangerous gushers took place when pressure was suddenly released from the oil traps. So these methods of control are referred to as blowout preventers. Another important concept we will be talking about in the course of our study is distillation of crude oil. Oil is extracted from the ground just as crude oil. It is then refined in the distillation tower that is divided into series of collecting trays at different temperature conditions. The crude oil is boiled to produce vapor. This vapor is then allowed to diffuse up the tower to cool and condense at different temperatures. And of course, as we shall soon see, the lightest compounds will have lowest boiling point temperature. As soon as this has taken place, the different components of crude oil can therefore be separated. So these are fractions obtained from crude oil. As you can see, we have fractions with the lowest boiling point right at the top, and then some of them are the gases, and then the naphtha, and then as you can see, apart from the gases and naphtha, the other substances we have as the fractions obtained from the distillation of petroleum include gasoline. Okay, and then we move down to kerosene, down to diesel oils, lubricating oils, fuel oil, and then the residue. You will notice that the fuel oil and the residue here, they have the highest boiling point. What are the uses of some of these substances? Let's quickly check those out. The gases. So some of these gases include propane and butane gases, and they are used for lighter fuel and camping stoves. The naphtha, these are chemicals for medicines, plastics, paints, cosmetics, and clothing materials. Then we have the gasoline, which are petrol for vehicles. Then we also have the kerosene, which are jet fuel and paraffin. The diesel oils are used for diesel fuel. Then we have lubricating oils. These are used for machine oil, waxes, polishes, and so on and so forth. Then the fuel oil. The fuel oil are used for ships and central heating. We have the residue, which are bitumen. They are used for road surfaces and roofing materials. Fractions that condense in each tray are extracted and used for different purposes. The smallest, which is the lightest, and the ones at the top, are hydrocarbon molecules that are used as gases. The intermediate hydrocarbon molecules are used in liquid form. And then we have the largest, which are the heaviest, and they are located at the bottom. They are hydrocarbon molecules that are used as solids, such as tar. An example of those is the bitumen. So as we continue in our studies, we are going to go deeper into some of these items that we have introduced in this first lesson. This lesson will end here, and I will see you in the next lesson. In case you are yet to subscribe to this channel, I encourage you to do so now. And if you like this video and you have learned something important and new today, go ahead and give this video a thumbs up. And I would also like to read. And very importantly, I'd like to read what you think about what we have just learned, what you have just learned. What do you think about petroleum? What do you think about the crude oil? What do you think about the coal and the natural gas? What do you think about the fractions distillation of petroleum and the uses of the various substances collected after the distillation? What do you think about these? I would like to read your comments in the comment section. Thank you, and see you in the next video.